Functions and graphs, the vertical line test. The vertical line test is a test that we use when we're trying to answer the question of whether or not a graph represents a function. So remember that the definition of a function states that each input must be mapped to exactly one output. The statement of the vertical line test says that if it's possible to draw a vertical line that intersects the graph more than once, then the graph does not represent a function. Otherwise, the graph does represent a function. So, for example, here, if I start trying to draw vertical lines, everywhere that I draw one, my line will intersect the graph only once. If you can draw a single line that gets more than one intersection, a single vertical line, then we will violate the definition of a function. However, in this first example, we can't, and therefore we would say yes, this does in fact represent a function. Going on to the next example, we can right away draw a vertical line that intersects the graph more than once. So we would say no, this is not the graph of a function. To see why the vertical line test works, all you have to do is imagine that you're evaluating this function for some value of x. If I say, okay, here's my x, this is a point with the same x coordinate that I chose and some y value. Here's another point with that same x coordinate that I chose. We'll call these x comma y1 and x comma y2. If I were trying to evaluate this function at this particular value of x, then I would see that that x gets mapped to two different y values. And this is exactly the sort of model that violates the definition of a function. So this would be an input and more than one output. So the vertical line test is a nice test, fairly easy to remember. We just want to remember when we use it. It's always when we're being asked to determine whether or not a graph represents a function.